Okay, so we are done with the introduction of this chapter, and this is actually the first topic of the unit, expressing concentration of solutions. Now solution पहले बनाना is crucial. Crucial मतलब difficult नहीं, but one has to be really accurate. आपने last year practicals में standard solution बहुत बार बनाया है, and that is why I have used this diagram as a representative diagram. This is how we do it. We take a definite amount, a known amount of the solute, then we take a volumetric flask as per the required volume of the solvent. अगर हमें 500 ml का बनाना है, we take that volumetric flask because it has a mark here which is a mark of that designated volume, right? क्या है solute, क्या है solvent, that is immaterial here. I'm just revising that preparation of a standard solution, and हम weigh करके फिर उसको उसमें dissolve करते हैं little amount of solvent में, and then we make up the solution by adding the rest of the solvent up to the mark, right? Now this solution, एक standard solution जो है, इसका definite concentration होगा. What is the concentration? Concentration of a solution is the amount of the solute dissolved in a known amount of the solvent or solution. Already किसी solution में आप और solute add कर सकते हैं, या आप pure solvent में solute add कर सकते हैं, and there will be a definite concentration of that solution. Now what is important is, after making the solution, you should be able to express that concentration, and we express this concentration in many ways. Now the various concentration terms which we use are, number one is percentage. By means of percentage हम बता सकते हैं. Now in this presentation there's a lot of theoretical stuff only. Solutions में ये बात interesting है कि जब आप lab में करते हैं anything related to solutions, it is more activity based. But here it is gonna be, we are not in a lab. I'm gonna talk a lot, and there will be just equations and written material in front of you on the slides. Now the first concentration term जिससे हम express कर सकते हैं concentration of a solution is percentage. Simple mathematics, expressed as percentage by mass. We can express it as percentage by volume or mass by volume. Now if we have a solid dissolved in a liquid, solid in a liquid, solid is your solute, liquid is your solvent. अगर आपसे बोला जाए कि percentage of mass बताओ इसकी, what will you do is, it is just the method of expression and you have to follow the steps. Agar you're asked what is the percentage by mass of a solid dissolved in a liquid, how will you express it? You will take the mass of the solute in grams. Whichever the physical state of that solute, you will express its mass in grams, present in 100 gram of the solution, right? We are not speaking of the solvent here. Percentage में हम पूरा solution ले लेते हैं. Mass of the solute in grams in 100 gram of the solution. W by W. We have taken both of them, solute as well as solvent, in terms of grams. That is why it is percentage by mass. Now if you are asked what is the percentage of volume, it is W by V. Why W by V? Because this is a solid dissolved in a liquid. Remember that. Mass of the solute is taken in grams, dissolved in 100 cubic centimeter or 100 ml of the solution. Solution इस वक्त हम in terms of volume ले रहे हैं. What are we talking about? Solid dissolved in a liquid. Next case, we'll come to this example later. Next case is liquid dissolved in another liquid. जो एक और common type of solutions है, liquid in liquid. Both solute and solvent are in liquid phase. Percentage by mass आपको ऐसे ही बताना है, W by W. In spite of the fact that your solute and your solvent are liquids, you will express it in terms of mass of the solute in grams in 100 gram of the solution. W by W. I have written same as above. Percentage by volume यहाँ क्या होगा? Volume of the solute in cubic centimeter present in 100 cubic centimeter of the solution. You take both of them in terms of volume. Cubic centimeter, or you can say ml. कितना ml of solute आप ले रहे हो? 100 ml of the solution में. V by V. So कब आप W by W express करोगे? कब आप W by V express करोगे? कब आप V by V express करोगे? You have to be sure of these two things. One, solution क्या है? Is it solid dissolved in a liquid, or is it liquid dissolved in another liquid? And what is being asked? Am I being asked percentage by mass बताओ कि percentage by volume बताओ? ये सारी चीजें अच्छे से देखनी है. Now एग्जाम्पल हमने एक लिया है कि अगर हम कहेंगे 10% सोडियम कार्बोनेट, व्हाट डू वी मीन बाय दैट? 10% सोडियम कार्बोनेट in terms of W by W, weight by weight means दोनों चीज़ों का आप in grams ले रहे हो. 10 gram of sodium carbonate in 100 gram of the solution. The total volume is, weight of the solution is 100 gram. यही चीज़ अगर आपको W by V in terms of W by V express करनी है, 10 gram of sodium carbonate in 100 ml of the solution. You have to be careful about the words gram कहाँ है, ml कहाँ है, because that is all that is there. It is just the method of expressing it. Now calculations, अगर आपके पास numericals है and you have to calculate something, these are the equations you use. Mass percentage of a component. Component can either be a solute or a solvent. लेकिन अगर आपसे mass percentage पूछा जा रहा है, what is the equation? W by W. Mass of that component, वो solute है या solvent in the solution, divided by total mass of the solution into 100. Multiplied by जब आप 100 करोगे तभी percentage आएगी. But this is mass percentage. If they are asking you volume percentage, V by V, you take volume of the component, whether it is a solute or a solvent, divided by total volume of the solution multiplied by 100. And then if they ask you mass by volume percentage of a component, then it is W by V. You take mass of that component divided by volume of the whole solution. वो component solute भी हो सकता है, solvent भी हो सकता है. Mass of that component in solution divided by total volume of the solution in ml multiplied by 100. Right? The next concentration term we'll talk about is strength. In terms of strength कैसे हम express करेंगे? As far as the definition is concerned, strength of a solution is the amount of the solute in grams. You're taking solute in grams. Present in 1 liter of the solution. इन सारी definitions में आप ध्यान रखोगे, हम solute को ले रहे हैं relative to the solution कि हम ले रहे हैं relative to the solvent. Strength में भी हम solute in grams देखते हैं present in 1 liter of the solution. Right? Now expressed in gram per liter, obviously if you are taking grams of solute in 1 liter of the solution, or gram per cubic decimeter. Unit out of this क्या निकलेगा? Gram per liter. For numericals, we'll do in the Google Classroom. Strength of a solution is this: mass of the solute in grams divided by volume of the solution in liters. This is strength. Next is molarity, one of the most commonly used concentration terms. लैब में आपने लास्ट ईयर जितने भी प्रैक्टिकल्स किए हैं उनमें हमने solutions specific molarities के ही बनाए हैं. फिर जब हमने टाइट्रेशन भी की उसमें भी we made solutions of definite molarities, and molarity ही फिर finally हम calculate भी करते हैं. What is it? It's the number of moles of solute dissolved per liter of the solution. Again, you're taking number of moles of solute, but with respect to the solution. Per liter of solution में कितने number of moles है. It is denoted by capital M. You know what the problem last year was. You do not write it as simple m. This is capital M. And इसकी definition से इसका unit आता है mole per liter, or you can simply write 0.1 m, capital M, which would mean 0.1 molar solution. Equation mathematically, this m, capital M, which is molarity, is the number of moles of solute divided by volume of the solution in liters. Also, you can express molarity in terms of strength, जो हमने इससे पहले concentration term पढ़ी. And this is the equation. This molarity can also be strength in gram per liter divided by molar mass of the solute in gram per mole. Right? Molar mass of the solute. Molarity आपको जब लैब में बनाना होता है किसी स्पेसिफिक मोलारिटी का सोल्यूशन, आपको वेट पता होता है या वेट पता करना होता है कि कितना मैं वे करूं इस सोल्यूट को सो दैट मैं एक स्पेसिफिक मोलारिटी का सोल्यूशन बनाऊं. फॉर एग्जांपल आई आस्क यू 0.1 मोलर सोल्यूशन बनाओ इस सब्सटेंस का, सो यू विल हैव टू वे अ डेफिनेट अमाउंट ऑफ दैट सब्सटेंस. द इक्वेशन फॉर दैट इज दिस: molarity is equal to W divided by molar mass into 1000 divided by V. W is the mass of the solute and V is the volume of the solution. आप कितनी मोलारिटी का बनाना है, आप कितना वेट लेंगे और आप कितना वॉल्यूम ऑफ योर वॉल्यूमेट्रिक फ्लास्क ले रहे हो. क्या आप 500 ml का बना रहे हो या आप 1000 का बना रहे हो या 250 का बना रहे हो. दिस इज द इक्वेशन यू यूज फॉर दैट. नाउ इन केस ऑफ आयनिक कंपाउंड्स, मोलारिटी की जगह हम टर्म यूज करते हैं फॉर्मेलिटी. Formality is used instead of molarity, which is what, if you have to define it, it is the number of gram formula masses of the solute dissolved per liter of the solution. Instead of m, obviously it will be represented by f. And what is this formula mass you're using it? It is simply the sum of atomic masses. जो ionic compound में जो ions होंगे वो किन atoms के होंगे, उनका atomic mass sum करके will give you the formula mass. We have written a simple example here. अगर हमारे पास 0.2 molar aqueous solution of sodium carbonate है, it will contain 0.4 molar Na plus ions and 0.2 molar carbonate ions. Why? Because in an aqueous solution, 1 mole of sodium carbonate will give us 2 moles of Na positive ions. The formula is Na2CO3. 1 mole of this substance will give us 2 moles of Na plus and 1 mole of carbonate ion. That is why in 0.2 molar aqueous solution we'll have 0.4, twice this 0.2 molar Na plus ions, and since carbonate ions का एक ही mole होगा, we'll have 0.2 molar carbonate ions. We'll do the numericals in Google Classroom. It will be more clear. Now after molarity, the next term is normality. How do you define normality? You can express the concentration of a solution in terms of normality. And what is that normality? It is the number of gram equivalents of the solute dissolved per liter of a given solution. Again, we are taking solute relative to the solution. But we have used a new term here. It is the number of gram equivalents. What is a gram equivalent? Gram equivalent किसी भी element का या किसी compound का is its mass in grams which is equal to its equivalent weight. इसका equivalent weight क्या होगा? वही value इसका mass होगा जो in grams. That mass becomes its gram equivalent. अब ये equivalent weight क्या होगा? We'll see in the next slide. I'll repeat this. Gram equivalence क्या होता है? It is the quantity of an element or a compound that has a mass equal to its equivalent weight. और वो mass of grams में express करते हो, it becomes the gram equivalent, denoted by capital N. This is the unit, gram equivalent per liter. Obviously the definition is this. This will be the unit, gram equivalent per liter, or you can simply write down capital N. 0.1 N means 0.1 normal solution. This N mathematically अगर लिखना पड़े, number of gram equivalent of solute divided by volume of the solution in liters. Also in terms of strength, this N is strength in grams per liter divided by equivalent mass of solute. We'll see what this equivalent mass is. N, again अगर आपको normality, specific normality का solution बनाना है और आपको weigh करना है वो solid, कितना आप weigh करोगे? This is the equation you use. N is equal to W divided by equivalent mass of the solute multiplied by 1000 by V. W is the solute in grams and V is the volume of the solution. Now we have spoken about equivalent mass in the previous slide quite a number of times. So we need to know what this equivalent mass is. It is defined as the mass of the element which combines with or displaces 1.008 parts by mass of hydrogen or 8 parts by mass of oxygen or 35.5 parts by mass of chlorine. हमारे पास ये जो scale है measurement की, it's a relative scale. We do not have an absolute value कि कितना mass of an element. It is relative. Relative to what? Relative to the scale of hydrogen, relative to the scale of oxygen, relative to the scale of chlorine. आप तीनों में से एक भी कर सकते हो. तीनों जरूरी नहीं करना होता है, लेकिन तीनों हम डेफिनेशन में लिखेंगे. इतना मास ऑफ द एलिमेंट जो डिस्प्लेस कर सकता है या कंबाइन कर सकता है विद दिस मेनी पार्ट्स ऑफ हाइड्रोजन, विद 8 पार्ट्स ऑफ ऑक्सीजन और 35.5 पार्ट्स ऑफ क्लोरीन, उस मास ऑफ द एलिमेंट, उस क्वांटिटी को हम कहते हैं उसका इक्विवेलेंट मास. अब कैलकुलेट कैसे करेंगे? डेफिनेशन तो याद रख ली. इफ यू हैव टू डू इट प्रैक्टिकली, हाउ डू यू डू दोज कैलकुलेशंस? कैलकुलेशंस की ये सारी इक्वेशंस है. इतनी सारी इक्वेशंस इसलिए हैं बिकॉज आई हैव टेकन डिफरेंट टाइप्स ऑफ सब्सटेंसेस. इफ इट इज एन एलिमेंट, अगर आपको इक्विवेलेंट मास ऑफ एन एलिमेंट निकालना है, atomic mass उसका divided by its valency of the element. If it is an acid, molecular mass of that acid divided by basicity of that acid. If it is a base, molecular mass of the base divided by acidity of the acid. If it is a salt, molecular mass of the salt divided by total positive valency of the metal ion. Positive valency सिर्फ लेनी है metal ion की. And I have written it twice, sorry. Oh, I have written it thrice. I have written it one more time. Sorry. Then equivalent mass of an oxidizing or reducing agent will be molecular mass or atomic mass. उस oxidizing or reducing agent का molecular mass or atomic mass. It can be a molecule, it can be an atom. Divided by number of electrons lost or gained by one molecule of the substance. If you are taking atomic mass of the oxidizing agent, you will divide it by the number of electrons lost by one molecule of the substance. If you are taking atomic mass of the reducing agent, you will divide it by the number of electrons gained by one molecule of the substance. We have more terms, but this will be a bigger file. We'll do those concentration terms in next presentation. Okay.